In this episode, we're going to talk about backups in a way that is useful even when you are not sitting at a keyboard practicing commands. Because the most important part of backup skill is not the tool you type, it is the thinking you apply. Beginners often treat backup as a single action, like copy my file somewhere, and they assume that if a copy exists, then they are safe. In real Linux environments, the hard part is choosing the right kind of backup for the kind of data you have. Understanding what the backup can and cannot recover, and proving that recovery will actually work when you need it. That is why this episode frames backups as decisions. Archive versus sync versus image, and then a mindset called restore validation thinking. Linux Plus questions tend to probe this decision-making layer because it demonstrates you understand how data is stored and how failures happen. If you can explain the strengths and weaknesses of each backup approach and describe how you would validate restores conceptually, you will answer backup questions with confidence. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. Let's start with the simple idea that a backup is only valuable if it lets you restore what you need, when you need it, in the condition you need it. That sounds obvious, but it forces you to think beyond making copies. A backup that captures files, but not their permissions, might be useless for rebuilding a Linux system where permissions matter. A backup that captures the latest version of a file, but not older versions, might be useless when you need to recover from a slow corruption that happened weeks ago. A backup that lives on the same disk as the original is not a real backup against disk failure. When you think this way, you naturally start asking what kinds of failures you are protecting against, such as accidental deletion, ransomware-style encryption, file system corruption, or hardware loss. The backup type you choose should map to those failure scenarios. This is why understanding archive, sync, and image is so helpful, because each aligns with different recovery needs. An archive backup is best understood as packaging and preserving a set of files, often in a single container, with metadata included. The key concept is that an archive tends to be a point-in-time snapshot of selected content, capturing the state as it existed at that moment. Archives are great when you want to move or store a coherent set of files together, such as a project directory, a configuration bundle, or a set of logs. They also tend to preserve file attributes and structure in a way that simple copy operations might not, which matters in Linux where ownership and permissions are part of the file's meaning. Another advantage of archives is that they can be stored as discrete units, like daily or weekly packages, which naturally supports versioning over time. The limitation is that an archive is often not automatically kept in sync with ongoing changes unless you create new archives regularly. In decision terms, archives are a strong fit when you want packaged, versioned, point-in-time capture of file trees. Sync-based backups are different because their intent is not packaging a snapshot, but keeping a destination aligned with the source over time. The mental model is a mirror that is repeatedly updated so the destination looks like the source, often copying only changes rather than rebuilding everything each time. This is efficient and can be very practical for large datasets where only small parts change between runs. Sync is also often used for operational resilience, such as maintaining a secondary copy that is ready to use quickly if the primary fails. The big beginner trap is assuming that sync automatically gives you historical versions, because many sync approaches aim for the latest state, not past states. If you accidentally delete a file and the sync runs, the deletion can propagate, which means your backup may faithfully mirror the mistake. That does not make sync bad. It means sync is best when you combine it with retention strategy or when your goal is rapid recovery of the current state. In decision terms, sync is a strong fit when you want an up-to-date replica and you understand how to handle versioning and deletion risk. Image-based backups operate at a different level because they capture disk or file system state as a whole rather than focusing on selected files. The simplest mental model is that an image is a representation of the storage contents in a way that can reconstruct an entire system volume. This can include not just files, but also file system metadata, partition structure, and sometimes boot-related information, depending on what kind of image you take. Images are powerful because they can support bare metal recovery, where you rebuild a system to a known good state after catastrophic loss. They are also useful when you need a consistent snapshot of a system that has many moving parts, such as an operating system plus applications plus configuration, where restoring individual files might miss hidden dependencies. The trade-off is that images tend to be larger, slower to produce, and more complex to store and manage, especially if you want frequent versioning. They can also capture a lot of irrelevant data, which is wasteful if you only care about a subset of files. In decision terms, image backups are a strong fit when you need whole system restoration and want to preserve the exact storage state. Now let's compare archive, sync, and image in the way Linux Plus questions often implicitly ask you to compare them. What exactly can you restore, and how quickly can you restore it? Archives typically restore a selected set of files and directories to a point in time, often with strong metadata preservation, but you may need to choose which archive version to restore from. Sync tends to restore the latest state quickly because the replica is already close to ready, but it can be risky if errors propagate and you do not have version history. Images restore a whole volume or system, which can be fastest for total recovery, but may be overkill for recovering a single file, and it can be slower to access if you need only a tiny piece. Another exam-friendly comparison is granularity. Archives and sync are file-level approaches, while images are block or volume-level approaches. That difference affects not only what you restore, but how you verify it, because verifying a file-level backup involves checking file integrity and metadata, while verifying an image backup involves proving the system can boot and operate. When you see a scenario in a question, you can often identify the best backup type by asking, is the goal file recovery, current state replication, or full system rebuild? It is also helpful to connect backup type to data type, because not all data behaves the same. User documents and configuration files are usually well suited to file-level backups, because individual files matter and changes are often understandable. Large collections of small files can make backups slower and can stress metadata handling, which might influence whether packaging into archives is beneficial. Databases and application state can be tricky because they may be changing while you are backing them up, which can create inconsistencies if you capture files mid-change. Even without going into tool-specific steps, the concept is important. Consistent backups require that the data you capture represents a coherent state. For image backups, coherence is about snapshotting a volume, while for file backups it can involve capturing a coordinated set of files together. Linux Plus questions often hint at this by mentioning active services or data that changes continuously, which is a clue that backup consistency is a concern. Your decision-making should include whether you need point-in-time consistency and how that affects your backup approach. Now we get to restore validation thinking, which is the mindset that separates people who have backups from people who can actually recover. Validation starts with a blunt question. If something broke today, could I restore, and would I know it worked? Many beginners validate backups by checking that a file exists on the backup destination, but that only proves the backup ran, not that it is usable. Real validation involves testing restoration paths and verifying the restored data's integrity and usability. For file-level backups, that might mean restoring a sample set of files into a safe location and confirming that permissions, ownership, and content look correct. For archives, it might mean confirming that the archive can be opened, that it contains expected paths, and that extracted files behave correctly. For sync, validation might mean confirming that the replica is complete, that changes are being captured as expected, and that you have protection against accidental deletion propagation. For images, validation might mean proving that the image can actually be used to reconstruct a bootable, functioning system. The exam loves this concept because it is a mindset more than a command, and it shows operational maturity. A big part of validation thinking is understanding that restore is a process, not a button, and processes can fail at different stages. You can fail to access the backup storage, you can fail to locate the right version, you can restore the wrong thing, or you can restore correctly but still end up with a broken system because a dependency was missed. That is why you should mentally separate restore mechanics from restore verification. Restore mechanics answer, can I retrieve the backup data and place it back? While restore verification answers, does the restored thing actually work the way it should? Verification might involve checking that an application starts, that configuration files are recognized, or that permissions allow normal access. For beginners, the biggest leap is realizing that recovery success is defined by usefulness, not by copying. A file that exists but is unreadable due to wrong permissions is not a successful restore in Linux terms. When you think about validation as usefulness, you naturally test the aspects that matter. Retention and versioning are also central to backup decision-making, and they show up in exam questions even when the word retention is not used. If you only keep the latest backup, you are protected against sudden loss, but not against slow corruption or unnoticed changes. If you keep multiple points in time, you can roll back to a known good version, which is critical when the problem is discovered late. Archives naturally support point-in-time retention because you create discrete packages, while sync needs deliberate design to prevent the latest state from overriding your only copy. Images can support retention but can be expensive in storage, which might limit how many you keep. The validation mindset includes verifying not just that backups exist, but that your version history exists and is accessible when you need it. A common failure pattern is having backups, but discovering during an incident that the only available backup is too recent and includes the bad change. Exam scenarios that mention long-term issues or corruption are often prompting you to think about retention rather than just copying. Another important piece is the relationship between backup strategy and recovery objective, which can be described as what you need to restore and how fast you need to restore it. If you need a single file quickly, file-level backups are often best. If you need an entire system back online fast, an image-based approach may be more appropriate. If you need a standby copy that can take over with minimal downtime, sync might be part of the plan, with safeguards for versioning. This way of thinking helps you answer Linux Plus questions that describe operational needs, even if you are not a working professional, because the exam often frames scenarios in terms of consequences like service downtime or data loss. You do not need to design enterprise backup architectures. You just need to match the backup type to the recovery goal. In your mind, it becomes a matching exercise, file-level snapshot versus replica versus whole system reconstruction. Once you can match those cleanly, the rest of the reasoning is straightforward. By the end of this episode, you should feel comfortable distinguishing archive, sync, and image backups by what they capture and what they restore. Archives package a set of files into point-in-time units that are great for versioning and metadata preservation, but they require ongoing creation for ongoing changes. Sync keeps a destination aligned with a source and can be excellent for fast recovery of the current state, but it can also mirror mistakes unless versioning and retention are handled deliberately. Images capture whole storage state and can enable full system recovery, but they tend to be heavier and are often used when you need to restore an entire machine or volume, not just a few files. Most importantly, you should carry restore validation thinking as a habit. Backups are not proven by existence. They are proven by tested restoration and verified usability. If you can explain these distinctions and this validation mindset, you are ready for Linux Plus questions that test backup reasoning. And you are also building a practical skill that matters in every Linux environment you will ever touch.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.